Hi everyone and welcome to my channel. In this video I plan to cover the topic of logs. It's done really in ADMAT and it's covered in Form 4 or in Form 5, right? So here I'll go through all the steps of logs and many examples, right? From simple to more complex ones. So please stay tuned in my video to see and hopefully understand better some log questions. So before I get into the rules of logs, let us understand how does log even work, right? So say for instance I had 2 to the 3, well we know that is 8. If I wanted to write this in a log form, I would write it like this. Log of base 2 of 8 is equal to 3. See here is that my value here, this 2 here, which I could call my base, has become the base here as well. Index value here, which is 3, is now like on this side here. And the value 8, which was the answer, is actually here. So what I see here is that when I had a 2 raised to the power of 3, which is 8, when I wanted to write this in terms of logs, I had to make this 2, which was the base value, this had to become the base value here as well. So this would work with any other value. So say I had 5 raised to the power of 2 is 25, then it would be log of base 5 of 25 is 2. Let's move to the calculator. On your calculator, scientific one that is, you may have two buttons, log, which is log, and ln, which is, well, ln, right? They both have different bases. This log here really has a base of 10. So whenever you see a sum and there's no base given, it's understood that it's a base 10. ln, however, has a base of e. Now, e is a constant value, and if you go to a calculator and I think you press second function, ln, you will get the e being 2.71828, etc. Right? That it goes on and on and on. Right? So if you are given a question and there's no base written, it's understood that it's a base 10. If it's a ln, well then that's understood it's base e. So now let's move on to the rules of logs. Rules of logs. So here we have the first one being product rule. If log to the base b of m by n, then this is the same as writing log b of m plus log b of n. Now notice it must have the same base here. Base b, straight through for this to happen. You cannot use a different log with a different base, and expect this rule to work, right? It must be like that. And so the quotient rule, the power rule, and the change of base rule. Now, I want to do a couple questions so that you all will understand how we use them. Say I was given log base x of 9 is equal to 2, and they said find x. Now, I want to remind you of the rule that we went through before, where I took 2 to the power of 3 is 8, and I wrote log of 2 of 8 is 3. Now, I'll write it with letters. I'll say x to the p is equal to y. So log of base x of y will be p. Now, applying this same logic here, well, from here as well, to this sum here, then I could rewrite this sum, and I will get x squared is 9. So therefore, x is really the square root of 9, so x is really plus or minus 3. So that, everyone, is the answer to my first question. If I were given log base 3 of x minus 2 is equal to 4, now I have to solve for x. So again, I rewrite it. 3 raised to the power of 4 would be x minus 2. So this simply means 81 is x minus 2. So x is 81 plus 2, 83. That's the end of my second question. My third question, find x again if we're given this. Now the first thing I analyze, okay, I'm seeing a log here with a base 5 and a log here with a base 5 and a number here, a constant here, right? So I like the fact that I have the same base, 5 and 5, but this 1 needs to be converted to base 5. Now I don't know if you know this, but 1 is actually equal to log 5 of 5, right? And that's another rule actually that's not mentioned here, which is log of a is 1. So now I'll put that. Now rewriting the sum, I'll get same log 5 of x is equal to now log 5 of 5 minus log 5 of x minus 4. Now I can apply this rule here, that is the quotient rule here, to this piece here, because it's log 5 of a value minus log 5 of another value, right? So I'll just simply write back this, and I'll write log 5 of this 5 here by x minus 4, right? Because, it will be divide by x minus 4. So easy to make mistakes here. 5 over x minus 4. Put brackets like this, right? So now once you have this, once I have log of a value is equal to log of another value, I could just simply drop my logs, this and this. So here I have x is equal to 5 on x minus 4. Sending this over, x minus 4 is equal to 5. Solving with a quadratic, factorizing, we'll get x minus 5 and x plus 1. So then I say x is equal to 5 and x is equal to minus 1. So I'll have two answers here. So that is the end of my third question. Number 4 now. I'm given this. First thing I do is analyze. I have a log base 2 here, log base 2 here, and a constant here. So I'm going to convert this constant here to a log base 2. Now if I have 3 here, it means that 2 raised to the power of 3 is give me 8. So that means I will write back all of this like this. And then I'll write log base 2 of 8, which is equivalent to 3, log base 2 of x plus 1, etc. And now I move on. This rule here, I apply the product rule, so I'll be multiplying. So I just write back everything like this. And then I put log base 2 of 8 by x plus 1. And now I could drop my logs, right? So I have 2x squared plus 3x plus 5 is equal to 8x plus 8, bringing them all over, and then factorizing, I'll end up getting this and this. X is equal to minus a half and x is equal to 3. That is the end of my fourth question. Another question here, number 5. It says LG of k is equal to 1 plus LG of 7. Now when you see the LG written like this, in some questions it simply means log. And as I told you from before, when there's no value here for the base, it's log base 10. So if they wrote 1, that just means this is this, and this is LG of 10. So again, simplifying and using the rules, I'll get LG of 10 by 7. So I'll get LG of k is LG of log of 70. Drop this, drop this. So then k is simply equal to 70. Sixth question here. Now, if I was asked to find x in a question like this, right? Now, some of you might say, okay, miss, I'm saying log of x over log of 4 is equal to log of 32 over log of 2. Okay, miss, so this is the same as the quotient rule. So you might say, okay, miss, I'm going to write this, right? This here is equal to this. Now, actually, guys, that is not true, right? Because it has to be log of one log here with a division sign here with two values would be equal to the log of one value minus the log of another value. Whereas in my sum here, I have log of x over log of 4. I have two sets of logs. This is not equal to log of x on 4. You all understand that, right? So I hope that you do. So please note, I will not proceed with this. This is wrong. So let me go to what I will do. So I will cross multiply. Cross multiplying now, I will get log of x by log of 2 would be equal to log of 32 by log of 4. Now all these will work out to be long values, right? So that simply means log of x is log of 32 by log of 4 over log of 2. Now punching this all into the calculator, I'll get log of x is actually works out. That's all of this here into the calculator. I'll get 3.010299, etc., right? So this means it's a base 10. So 10 raised to this power here, if you put that in, will give me x. And that works out so to be almost like around 1024. So that is my answer for x, right? So that's the solution for number 6. Now let's move on to number 7. Now, in this question here, you might say, miss, but there's no log here. How do you know I have to use log? It's only indices. So the first thing you say, okay, I have 3 raised to the power and is equal to 2 raised to the power. Now 3 and 2 are not connected in any way. It's not like 2 and 4 or 2 and 32 or so, right? So 3 and 2 not connected by indices. So that means I will have to use logs. So if I apply logs to both sides, it's like if I just stuck in a log here and a log here, and then this value comes in front, it becomes x minus 1 log of 3, x plus 1 log of 2. Now all of this is multiplying here and all of this is multiplying, right? So simply bringing them over, I'll get x minus 1 over x plus 1 is equal to log of 2 over log of 3, right? So this works out to be a constant here. It doesn't really help my situation if I have a value on this side like this, right? So what I think I should actually do, even though this is not wrong, I should actually just expand here instead. I should say x by log 3 and minus 1 by log 3, x by log 2, and so on. So then I'll get x log 3 minus log 3 is equal to x log 2 plus log 2. Now you could always do that. Start a particular way and then change your mind and go another route, right? Now this works out nicer. X's, now I'll get x log 3 minus x log 2 is equal to log 2 plus log 3. Factorizing x now, I get log 3 minus log 2 here, log 2 plus log 3 here, and just sending it over, I get x is equal to log 2 plus log 3 over log 3 minus log 2. Simplifying this here now, I'll get log of 6, right? Because this simply means log 2 plus log 3 is log 2 by 3, right? So that's log 6, that's the numerator. Log 3 minus log 2 means log 3 divided by 2, which will actually be log of 1.5. So then this here, guys, would be the answer. Log 6 divided by log of 1.5. So I hope you understand what I did there, right? The log 2 plus log 3 with rules of logs with product, it means log of 2 plus 3, 2 by 3, sorry, which is 6. And log 3 minus log 2 is quotient rule. So it will be log of 3 divided by 2, which is log of 1.5. So this is the answer. Now, moving on to my final question. This is my 8th and final question, right? So they said calculate log of this, log base 2 of log of this, right? Now we see now log and a log. So that looks a little complicated. So what I would simply do is I would just write is equal to x, right? So this is, I'm going to use some colors here. If I were to color this up here like this and say, let's let this be equal to y. And is y, so I'll get log of 2, sorry, log base 2 of y will be equal to x. Converting this to regular indices, I'll get 2 to the x is y. So nice. So if I could simplify this to get me one value here, like a y value, then I could just go to this line here. So let's work with this one here now, the yellow section. That says log of 7 of 49. I need to work that out. So let me put that equal to, say, capital E. So this means 7 to the E is 49. Okay, so that's easy. E would be 2, because I could just know that, right? I could just watch it and know that, right? So A is 2. So then everyone, this value here is actually 2. Rewrite my sum, I can write back the 2 to the x is equal to y is now, here I'll put 2. So if 2 to the x is equal to 2, then that's 2 to the 1. So therefore, guys, x is 1. Okay, so to just recap with the sum, because I know you're probably not accustomed to seeing a question like this, right? When you're given log of a value, log of a value, and then that is being logged as well, right? The first thing I try to do is work out the inner piece, this yellow section here. Now, nicely, I had 7 and 49, so that worked out to be 2. So this sum really was log base 2 of 2 is x. So then 2 to the x is 2, and that's how I got x is 1. Right? So that's simply my steps in when I have a question like this. So anyway, guys, this takes me to the end of my video. I went through 8 questions. I went through from the basic to the more complex one. I hope at the end of these 8 questions that you all understand the steps on how to really break down your log question and actually get your solution. It's really, really not that difficult. Right? So please, feel free to subscribe to my channel to see whatever else I have and whatever I'll be doing in the future, because I'm always doing more videos when people ask. Thanks, guys, for tuning in.